Hey everybody, it's Dallas here. I'm going to walk you through a single cycle in this review, brainstorm, research, plan, and execute LLM-assisted development workflow. The first one is review. So in your case, you're going to use LLM assistance to review your assignments 5 and 6 and the midterm project requirements. And basically what that means is something like just loading the files into your LLM. So in this case, I said, hey, Claude, check out what Codex and I accomplished earlier today. I gave it access to the midterm project, Markdown and docx files. There's not any substantial difference there, really. But then also the outline for presentation 14, which I delivered on Monday, so yesterday. And then the actual PowerPoint and PDF files for the presentations. And I just said, take a look at these. And that's all I said. So Claude looks at the files and says, this is solid work. The assignment document's well structured with clear requirements, grading criteria, and suggested workflow. So this response that Claude gives me demonstrates that it looked at all the different files and understands. And especially this second observation here, Claude says, presentation alignment, presentation 14 walks through exactly the workflow the assignment recommends. So the assignment, presentation 14 has this LLM assisted development cycle, and it matches what is in the midterm project assignment document, is what Claude is saying here. So this indicates to me that Claude has some understanding of this cycle that I'm about to walk through here. Then Claude asks me, what would you like to do from here? And it suggests some basically maintenance stuff for the documents that I showed it. I asked whether we want to work on those or maybe something else entirely. And I said, this is my response here. I said, the slide quality is good. The old presentation outlines have been renamed. The docx version is confirmed. And also all of these things here that it suggested doing, they've already been done. Like I did those on my own. But what I would like for Claude to help me do is to help me develop a demo that walks students through one cycle of this review, brainstorm, research, plan, execute flow. So I'm having a conversation with Claude here about creating a demo for you that you're watching right now um, in order to demonstrate this cycle. So this block right here, or this exchange, that's basically the entire first phase, this review phase. Um, you do something similar with your own assignment 5 and assignment 6 and the midterm presentation assignment, or but you give Gemini or Claude or whatever LLM that you're using access to those files, let them read it, and then from there, then you start having a conversation about like what you're going to actually demonstrate. And the PowerPoint here on this slide says you want to identify the 2 attack vectors with the strongest potential for interactive demonstration. You can do that here in the review phase, or you could do it in the brainstorming phase next. You know, there's not like a strictly defined place where this can happen, but you want to do these along the way. All right, so once I've given it this information, I say, I'd like you to help me develop this demo. And then Claude automatically just starts brainstorming on its own. So this brainstorming is a skill that Claude has. And the way that, so like if you type in /skills, it's a slash command that shows you different skills that Claude has. And a skill file is just, it's a plain text description of something that Claude can do, and it gives Claude instructions to do things better depending on what you're asking it to do. In this case, Claude invoked its brainstorming skill down here because either because it knew that it was going to have to kind of think about like what I was asking it to do, or perhaps because it understood that we were in the second phase already. I'm not really sure. It was probably just a coincidence that Claude used this brainstorming skill. But anyway, so Claude starts thinking and says, good, now I've read through assignments 5 and 6, the student topic selections, and the midterm project requirements. I've got a solid picture of the pipeline. And it starts asking me questions. So that's part of the brainstorming skill, is like asking the user clarifying questions. If Gemini or whatever LLM assisted tool that you're using, if it doesn't ask you some clarifying questions. You might prompt it to say, okay, what do you want to ask me about this that you don't currently understand? Uh, so prompting the LLM to ask you questions is a very helpful way to clarify for the LLM what it's supposed to do. So the first clarifying question that asks me is, do we want to walk through this live in class today? It thinks it was, this is yesterday whenever I was having this conversation with it. So it thought that maybe I was going to walk through it live in class with you, or we're going to record it and prepare it as a reference artifact, which is the correct answer there, yes. So I'm currently recording this as an artifact that you guys can watch anytime you want to. So I answered B to this question. It says, good, okay, next question. Which student's topic should the demo use? And it suggests a few different topics. So should we make a demo about reinforcement learning or continual learning, catastrophic forgetting, or something else? And I chose C because I wanted to demonstrate an attack vector vulnerability that no one else in class might. There may be some related topics, and some of you might use what I'm going to demonstrate here today in yours, but you got to do it completely differently. So anyway, I just wanted to make it, like fresh and potentially illuminating for you. So so after I've said, I want to demonstrate a topic that no student chose, it says, okay, which unchosen topic do you want to use? And it gives me several different topics that nobody chose. It recommends attention and transformers or model distillation, but I'm more interested in D. So this topic here, model rot and concept drift. So I say, I'm interested in D. What might an interactive demo of this concept look like? Could we use a small pre-trained model to demonstrate this concept? How might users interact? I'm thinking this might be too big a project, but maybe doable. Then Claude answers, compliments me, good instinct on both the interest and the concern. Let me think through this concretely. Then suggests what concept drift might look like interactively and addresses the technical feasibility of this. So we're still in the brainstorming phase here. We're just like thinking about coming up with ideas about how we might implement this. So use LLM assistance to explore multiple possible artifact concepts for those attack vectors. Focus on scope and format. Choose an artifact medium that fits the attacks. Produce a plain language description of the artifact in brainstorm.md. So far, I haven't saved any artifacts here, but I'll show you a little bit later on where that actually happened. So this is still brainstorming phase 2. It asks me, is this worth proceeding, or does the scope still feel uncertain? I said, well, the way you presented it seems doably small, so let's proceed in this direction with the intention to create a minimal demo that we may refine later. Now, onto the research phase. What tech stack? You mentioned Streamlit, Flask, JavaScript makes sense here. Any other options to consider? So here, again, this is where Claude mentions Streamlit or a Flask app or something like that. In the research phase, so this is research about technical implementation. Use an LLM assistance to conduct technical research on the most promising ideas from the brainstorming step. Identify compatible tech stack, including language, libraries, frameworks, and any local tooling requirements. Right? So here, I ask, what tech stack makes sense here? Are there any other options to consider? And it gives me some other options. So there's 4 options. I've used Flask and JavaScript. I've done a little bit of Jupyter Notebook. I've never used Panel or Gradio. I've also never used Streamlit before, but it's the recommended option. So my response to Claude is option A sounds like a winner the way you talk, but I'm unfamiliar with Streamlit. Can you help me understand more about it? And this is one of the big things that LLMs can help you do. Like it's going to present options to you. You're not going to understand them. So use this as an opportunity to learn about whatever, the framework is. So then Claude starts explaining what Streamlit is. It's a Python library that turns a plain Python script into an interactive web app. How it works, very, simple apps or simple, Python code can turn into a web app. And then it gives some advantages, disadvantages, how you install it, and also notes that if any of you choose Streamlit for your midterm project, you'll find plenty of documentation and examples. It's widely used for machine learning demos specifically. So before just green lighting this use of Streamlit, I want to make sure that it's not a hallucinated library or something like that. And so I just Googled Streamlit. It looks like it is indeed a very well supported and well organized library. So I say, yes, let's move forward and start planning the implementation. All right, so now we're in the planning phase. Again, review. I fed it a bunch of context and basically, helped wrap its head around what it is that we're trying to do here. In brainstorming, you creatively think of a bunch of different ways that you might implement. That includes, what the artifact might look like, how the user might interact, things like that. In the research phase, I'm gathering resources about the tech stack, the language, like the actual implementation of whatever we might do. And then now that we've gone through those phases very quickly here, it's time to plan. So we know what we're going to be demonstrating. We know what tech stack we're going to be using. Now it's time to make a plan. So Claude lays out a basic summary of the design. It's a concept drift interactive demo, the Streamlit app that trains a simple classifier on synthetic two-dimensional data, then lets the user shift the data distribution and watch the model's accuracy degrade in real time. This is just 2D data, very simple, like points on an XY plot. The core interaction it describes here, there's an initial state, drift slider, a metrics panel, and a retrain button. The technical components, you got to generate some data, train a very simple model. It says trains instantly, produces a linear decision boundary that's easy to visualize. Visualization, we're going to be using the matplotlib library and framework using Streamlit. So actually this scikit-learn library, logistic regression, I'm not familiar with it personally, so I just wanted to double check that it also was a valid library, and it is. So here on the official scikit-learn webpage, logistic regression is. So that's another, you got to check and make sure that the things that LLMs are telling you are in fact true or do exist, that they're not just hallucinating. Okay, then it gives me an example of what the file structure is going to look like. There's just a very simple app.py script. There's a requirements.txt file, and then a README that describes how to run it. It's going to be mapping what it calls two attack vectors, but actually the natural drift and adversarial drift injection, to me, they're the same thing. I mean, like it either happens naturally or it happens because some, like attacker is making it happen, but it's the same concept. And so this artifact, this interactive artifact, just is going to be demonstrating one of the two attacks, even though Claude thinks it's two attacks here. But they're so closely related that I wouldn't consider them separate or meaningfully, different as described in the midterm project assignment document. Okay, so then also Claude says what we're deliberately leaving out, so we're scoping it down. It asks, does this design look right to you, or do you want to adjust anything before we build? So just for the first iteration of this cycle and the quick demo that I'm trying to provide for you, this looks okay to me. So I say, yes, that sounds great, but let's first make sure that we record the results of our review, brainstorm, research and planning phases in appropriately named files. So I say review.md, brainstorm.md, research.md, and plan.md. All right, so that's where, um, in each of these steps, I advise you to save the work in like review.md or brainstorming.md, research.md, plan.md. And that's just so that you can, so that later, if you need to go back and look at it, you can find it very easily. And also, whenever you're assembling your report at the very end, you can talk about what the different iterations accomplished or what you learned along the way. Okay, so then Claude just asked me a question about where I would want to put this because there's already a folder I've got in my course materials folder. It's called demos, so it put this here. And then for iteration one, here's the review, brainstorm, research, plan files, and then later we create an execute file also. So it writes all of these, the review, brainstorming, so the different things that we talked about, the decision we came to, planning, nope, research is next, talks about why we chose Streamlit, what other options we considered. And then for planning, this is the actual implementation plan that Claude's going to use. So it's got step 1, step 2, step 3, visualization, step 4, step 5, and then down here at the bottom, acceptance criteria. So part of this plan is like we're going to build this thing, but at the end of it, we need to test it and verify that it works the way that we think it's supposed to be working. So it's got some acceptance criteria down here. The app needs to launch using this command. The initial state of the app needs to show high accuracy with clear decision boundary. The natural drift slider needs to visibly shift data and degrade accuracy. The adversarial drift slider. So this adversarial drift slider comes from, yeah, attack 1 and attack 2. Where was it? Sorry. Yeah, so it doesn't show it here in the core interaction. It says the drift slider. User drags the slider to shift one or both class distributions, points, move, decision boundary. Doesn't. Okay. But it does mention here attack vector mapping. Attack 1, natural drift. The environment changes organically, and attack 2, adversarial drift injection. So that is where somehow along the way, like from this spot here to, I said, let's make a plan, and put all of these, record these different phases in Markdown documents. And so just that process of getting Claude to think about what we've done so far probably impacted each of these documents here. So nowhere was an adversarial drift slider mentioned earlier in our conversation, but after looking at all the different, the things that we've talked about, and then deciding to write these documents here, it must have figured out that an adversarial drift slider would also be a good idea. It's really amazing watching these things work and trying to analyze what's happening under the hood. Okay, so then Claude writes review.md, brainstorm.md, research.md, and plan.md. And then says all 4 phase documents are written. Great. Asks me, are we ready to move into the execute phase? I said, yes, let's move on to the execute phase with a smiley face. So now Claude starts writing code, writes requirements.txt, which is here, just 4 requirements. It's going to write the app.py code, which is here. So as it was writing these, I looked through to verify what was happening, but I mean, I can understand basically what's going on here, but there's a lot of this that I really, to really understand how it works, I would have to spend more time reading, which is okay. And especially for something this simple, I could probably learn a lot. But for right now, just because it's the first iteration of this demo that we're trying to create here, I skipped through it. I mean, like some of the things are, I just like trust that Claude is going to come up with something at the end of this process and that it's going to work okay. And if it doesn't work, or if it doesn't work the way that I want it to, then I can go through later on and modify it. Okay, so it's going to install some dependencies, ran into a couple of errors here. It discovered that there was a redundant call in the plotting function. So it updated this code and it removed this line here, or these 2 lines. And actually at this point, see if I can find it. Yeah, so I said the error in both cases had to do with the timeout function called. So I saw that, what was it? Yeah. So there were 2 different times here where there was an error that got kicked back that had to do with the way that Claude was calling timeout. And I thought that that had something to do with this error that popped up here. And so I said, no, don't make that change in the code because the error that we're actually seeing involves timeout. But it said, good question, no functionality was lost, 2 lines were, and it explained to me why it removed that and what like what the reason for the bug was. So it explained it to me in a way that seemed feasible. You shouldn't always trust that that's like what's happening, or that the LLM is giving you an accurate description of why it took some kind of action. But in this case, it seemed reasonable that it was calling a function. It explained why the way it was calling the function in the first place didn't work. And so we kept on moving. Then it runs the code, it runs the app for the first time. And it finds two things. So the baseline accuracy of this app as it's running, like there's a data set, there's a model that's trained to classify these data points into one of two different groups. And after training, the model does so with an accuracy of 96.7%. Like the model, what it, its algorithm for separating the two classes does so with good accuracy. And with the natural drift slider set to 2.0, that decreases the accuracy. So that is successful. But the adversarial drift slider set to 2.0 actually improves the accuracy, and that should not be happening. So Claude says, all components work. One thing to note, adversarial drift at 2.0 shows 98.3% accuracy, which is counterintuitive. That's because the adversarial direction I chose shifts class 1 away from class 0, making them easier to separate. So actually what's happening is there's a bunch of different data points that each belong to a specific class, and the adversarial drift pushes it, like further separates those two classes of data points. So you'll see what I'm talking about in just a second here whenever we get the app. Anyway, Claude makes a change in the code that changes the adversarial direction from a positive to a negative vector, which should move it closer to rather than further away from the class 0 data objects. Okay, so then we go through trying to run. There was an error there, and now it's checking it again and showing that as the adversarial drift goes up, the accuracy goes down. And so that is behaving as expected. It says that's the right behavior. Accuracy degrades progressively as the adversary pushes class 1 into class 0's territory. And let me do a full run of the Streamlit app to make sure it launches. Oh yeah, and here's where the timeout. So there's two different timeout function errors where it's not finding timeout. So I checked it on that. It gave me an explanation of what was happening. Then we tried launching it live. It gave me the command to run this, and that actually didn't work. So it doesn't look like it's running. Then I had Claude launch it directly. And here's what it looks like. So this is the actual app. Kind of want to zoom out a little bit. Let me just do this. Okay, so here's the app that we created here. It's interactive. So it changes with, so every time that I'm moving the slider, it's responding. You can see gradually what's happening. So what does this mean though? You can also reset it to original, move it back, reset to original. Okay, so what are we looking at here? There are a whole bunch of data points. There's a decision boundary. There are two different classifications here. There's class 0 and class 1. So I mean, technically this is a very abstract representation of how this machine learning algorithm is working. But it's kind of hard to tell what exactly is going on here. Down here below, there are some paragraphs that describe what's happening. Attack number 1, natural distribution drift. Natural drift slider simulates gradual environmental change. What retraining shows. So there's a little bit of information here, but it's not really good enough for me. I mean, like it's a good start for sure, but I shouldn't just stop here. I mean, like there's a lot left to do. But everything, the sliders work the way that they're supposed to, and that's great. Reset to original. All this retrain on current data button should work and do something. And then it's even worse. Okay, great. So now we are all the way through the execute phase. We're almost all the way through the execute phase. So we've executed on this plan, and I'm going to ask Claude. Yeah. Okay, I say, all right, it's working. However, I've noticed a few things that I'd like to improve upon in the next iteration. Let's create an execute.md file for the first iteration that summarizes our work and the results. By the way, are all of the acceptance criteria in plan.emd satisfied? And again, those acceptance criteria are here. So does the app launch? Does the initial state show high accuracy? Does the natural drift slider visibly shift the data? Does the adversarial drift slider shift the data? Does the retrain button recover accuracy? Does the reset button? And is there explanatory text present for both attack modes? And you can see that that is true. All of these things here are working. So all of those acceptance criteria. So planning makes a big difference. Like if you set the goals at the beginning before you start building anything, as to like what needs to be true in order for this to be successful, then Claude can check. So Claude says, let me check the criteria against the running app. It says all 7 are satisfied based on the code and smoke tests. So it says all 7 are good, but it says the one thing I can't fully verify from here is whether the retrain and reset button behave correctly in the live UI. That's something you can confirm as you interact with it. Do they work when you try it? So even though it asked me this question, it says I can't confirm this. Let me go ahead and write the executive summary. And it writes this summary that shows that all of the acceptance criteria have been satisfied. Yep. So it says retrain button and the reset button, even though it just over here told me that it can't verify this. Here in the execute.md file, it marks these as complete. So so I just wanted to make sure that they did work. So I checked the buttons in the browser and they do. And I said, yes, and you're correct that the retrain and reset buttons work as expected. I manually verified this. Okay. So now Claude says, good, all 7 acceptance criteria confirmed. What are the improvements you noticed for iteration 2? So now we're back to the review phase again. So we went through review, brainstorm, research, plan, and execute. Now we're back to review. And in this case, it's going to be like reviewing what went well, what went badly, how can we improve it? Does the code run? Does the artifact demonstrate the attack? How can we make it better? What's missing? That type of thing. And then, we'll brainstorm and research and plan again. So I said, yeah, all right. So we're now in iteration 2 review phase. Here's what I noticed. The app, although it works as expected, doesn't do a great job of explaining what's actually happening to a user who may not understand how the model was trained, what the data might represent, why a model might lose accuracy over time as the world data shifts, and how an adversary might poison or otherwise attack the data set or model or cause drift. So those are the things that, like, that's going to kick off our second review iteration. And from there, Claude asked me some questions, but I'm going to stop the demo here just to show you that, I mean, this had happened, some number of times. And um, the files that you save along the way will not only help you write your report, but they'll also demonstrate the iterative cycles that you went through. If you want to include those or talk about how many, iterations you went through the cycle, I think that would be really valuable for your midterm project assignment as well. And yeah, good luck with working on this project. If you need any help or if you have any questions, let me know, and I'll get back to you as soon as I can and try to help you in any way that I'm able. Thanks very much. Later.